Okay, good afternoon all. I'm going to start the class for today. Today, today we'll continue to discuss the module heat treatment. And in the previous class, we have discussed about the heat treatment, procedure of heat treatment, and different stages of heat treatment. Yes, anyone want to say something? I think someone is telling something. Oh, please don't disturb by writing your roll numbers and all. Take the attendance from the Google form. Okay. In the previous class, we have discussed about the process of heat treatment, the general process of heat treatment, and the different stages. Those are used in the heat treatment of different metals and non-metals. Now, here the most important metal, that is steel, in the sense of civil engineering view, and the heat treatment process for steel is important topic which is actually referred in your syllabus. And now we're going to discuss about the treatment processes, different treatment processes of steel, different heat treatment processes of steel. There are mainly four types of heat treatment process for steel. One is hardening, secondly tempering, thirdly normalizing, and fourthly annealing. Now, maybe in any of the books you may have the serial not like this. Maybe you have at number one annealing, then normalizing, then tapering like this. But as your syllabus refer, the first process in your syllabus which we have to discuss, that is hardening, and that's why I have take hardening as the first process to treat the steel by heat treatment. Okay, now Now, in the previous class, we have already discussed that heat treatment is nothing but a process by which the metal or the non-metal or any of the alloy will be hardened or will be strengthened. Now, in the point of view of steel, obviously, to harden the steel, to modify or to improve the characteristics, strength characteristics or hardness characteristics of steel will be improved by this heat treatment. And hardening, this name itself refers to uh, give or impart more or improved value of hardness of steel by this process, that is hardening. Hardening means obviously impart more hardness to the steel by some process, that is hardening, and this hardening is the one of the process of heat treatment. And first of all, the uh, broad front is representing the two stages of hardening. First of all, the heat will be given to make the steel heated and to rise the temperature to some specific temperature value, and then in the next stage the heated steel will be cooled down, and this rapidly the heated steel is cooled down to some temperature, and this cooling down process, this cooling down stage is done by put the hot steel into some oil, water, or some brine water mixture. Brine water means you may not have the idea of brine water, but that is simple. Brine water means the mixture of water or any common rock salt. Maybe that table salt, maybe the mixture of water and common uh, table salt. That is actually brine water, and the temperature will be reduced when some rock salt, common rock salt, will mixed with the water. That's why this type of mixture is used for cooling, and this rapid cooling procedure, a rapid cooling stage, is done by putting the hot steel into some cool cold oil, cold water, or some brine mixture. Okay, now this process, this cooling stage is named as quenching. This cooling stage is named as quenching. That is the total process. The hot steel is put into or plunged into cold water, oil, or brine solution to make it cool rapidly. Obviously, this rapidly term is very much important here. This rapid process is called quenching, and this this rapid cooling may not be used for some hardening process. In those cases, air cooling process may be used, but that is not called quenching. Some of the cases of hardening, air cooling may be used. Air cooling process may be used for the second stage, but that air cooling process is not called quenching. Quenching is called when this cold water or cold oil or brine solution is used to make the hot steel cool rapidly. Okay, that is actually called quenching. But this process, when cold air or cold air is used to cool the hot steel, then that process is not called quenching. Now this is the two stages of hardening. Now Now here I have just discussed the different uh, characteristics and different factors of hardening in a brief manner, and uh, in the first paragraph I have just discussed about the effect of hardening on the steel. Now hardening is obviously this is obvious that hardening is the process to harden the steel or improve the hardness characteristics of the steel and obviously strength of the steel. But by making the steel more hardened or making it more strong, that will make it brittle also. Generally, by hardening the steel, obviously the steel will be more brittle. But to reduce the importance of this brittleness, we may uh, temper this term temper. We may temper the steel, and if we go to the four process of heat treatment, there is one treatment that is called tempering. And after hardening the steel, to reduce the imparted brittleness in the steel, we may get help from this tempering process. And tempering means nothing but to heat the steel by some heavy weight. That is the simplified form or simplified process of tempering. And uh, and obviously, by tempering the hardened steel, we may reduce the brittleness of the steel and to increase the ductile property of steel, hardened steel. Now, in the second paragraph, I have just discussed the heat treatment of hardening may be used only for steel or carbon steel because pure iron, wrought iron, or any other of iron, or maybe very low carbon steel. We have discussed about different carbon steels where the amount of carbon is very less, that is 0.1% to maybe 0.2%. That is called low carbon steel. These types of steel where carbon amount of carbon is very less, or any of the iron having little or no hardening capability, no hardening capability. That means those types of iron or those types of low carbon steel cannot be hardened by this hardening process of heat treatment. But cast iron having a little capability to be hardened. But in that case, when cast iron is cooled rapidly in the second stage of hardening, that means this stage, after heating, we have to uh, cool the steel rapidly. If cast iron is go through this second stage, that means cooled rapidly, then it forms a special type of iron which the color of which is white. That means some white iron is formed, and these types of iron, this white iron is hard and brittle. That means hardness characteristics improve, but ductile characteristics is decreased, and that will be brittle. And obviously, this rapid cooling may be the process may be slowed down for this cast iron, and in that case gray iron is formed, and this gray iron is soft and brittle under impact. That means if rapid cooling procedure is not used but slow cooling procedure is used specially for this cast iron, this is a special case of cast iron. I am just discussing and just describing. If steel, not using steel, some iron material is used for hardening, what will happen? That in the pure iron or wrought iron cannot be hardened at all by this heat treatment, but cast iron may be hard. Maybe the hardness property of cast iron may be improved by heat treatment of hardening, but in that case rapid uh, cooling is to be used, and in that case also hardness may be improved but brittleness uh, also increased. But if cooling slowly, then gray iron will be formed, and that will be soft also. That means hardness properties also not be improved. Okay, now in the next uh, paragraph, the factor which is the most important factor, that is uh, that has an impact on the hardening process. That means most important factor which is on which the hardening process is dependent, and that is the carbon content. This is the most important factor on the hardening process. And carbon content, if we increase the carbon content, that is amount of carbon, then the hardening of the hardening of the steel will be increased. But this amount, the 0.8% amount of carbon is the optimum amount of carbon. After that, if we continue to increase the carbon amount after this 0.8%, then the hardening of steel, that means the hardness of steel, will not be increased. And in that case, after 0.8% of carbon in steel, the wear resistance of steel, wear resistance of steel will be increased. Obviously, that is the improved characteristics of steel, that is wear resistance will be increased, but that is not because of carbon, or that is not because of hardening. uh, by heat treatment. That is not because of hardening or by heat treatment, but that is due to the formation of cementite. And I think you have the idea about cementite. Cementite is nothing but ferrous carbide. We have discussed in the phase diagram of iron carbon system. Ferrous carbide. This cementite is nothing but ferrous carbide. And due to the formation of this cementite, this ferrous carbide, the wearing resistance will be increased, and that is not due to the hardening or the heat treatment of the steel. That means in practical cases, in all the practical cases, the carbon amount of carbon will be 0.8% to make the steel. Now, now this is some uh, characteristics of the process of quenching, and quenching is done uh, in case of carbon steel. Quenching is done by using brine or water. Brine is nothing but the mixture of water and common rock salt. And alloy steel means uh, steel having mixed with some other material like nickel or cobalt, like that, with carbon obviously, and alloy steels are generally quenched in cold oil. Okay, now now uh, now this quenching procedure is done rapidly, means this 1000 degree Fahrenheit temperature will be get to room temperature in 1 second. This is the rapidity of this process of quenching. Okay, and this time limit, that is 1 second, may be slightly greater when the alloy steel is used to harden. Alloy steel is hardened, then this rapid cooling process may be done uh, in greater than 1 second limit, but in less than 1 second this cooling process is done for carbon steel. And the quenching procedure is done by remove the remove the quenched steel from the quenching bath at a temperature of 200 degree Fahrenheit, and after removing it from the quenched bath, it is allowed to air cool. And this temperature, the reducing of temperature from 200 degree Fahrenheit to room temperature is called cracking range. And obviously we don't uh, pass the steel after making it hardened. We don't pass the steel through this temperature, that is 200 degrees Celsius to room temperature. That is all about the hardening process by heat treatment. This is the first process of hardening, and that is the hardening process of heat treatment. These are the stages of hardening, two stages of hardening. This is the effect of hardening on steel. This is the effect of hardening on iron, and obviously uh, which types of carbon or steel may be hardened by heat treatment, that is described here. In the next part, the factor which has the impact on hardening, that is the carbon content. Only the carbon content have the impact on hardening process by heat treatment. This is described here, and this is the procedure, a simple procedure of cooling or the quenching, that is described here. This is all about hardening process. And here I have just make a small chart, that which type of material related to, obviously ferrous material, which types of material, ferrous material, having the quality to be hardened, that means iron and low carbon steel have actually little, very less capability or no capability to be hardened. Cast iron having a limited capability of harden, but that is done by rapid cooling. If that hardening proceeding is done by slow cooling, then that cast iron will not be hardened, but that will be soft. And the main material, that is plain carbon steel or alloy steel, will be hardened by heat treatment properly, and in that case the amount of carbon will be increases to increase the hardened property, hardened capability of the steel. But 0.8% carbon is the optimum carbon amount up to which hardening capability of steel will be increased. After that, after the 0.8% of carbon, that will be not hardened and hardened further, and obviously that will be having an another property, improved property, that is wear resistance properties, but that is not due to the hardening by heat treatment, but that is due to the formation of hard cementite or ferrous carbide. This is all about hardening by heat treatment, hardening of steel by heat treatment.